dual input, balanced output differential amplifier circuit. It consists of totally 2 NPN transistors are there. It has 2 NPN transistors are there. Both are identical to each other. Even though we are using the 2 same type of transistors, NPN and NPN, but there is a difference in at least one internal value of, say, even though this is NPN and this is NPN, both seems to be similar and same, but both, even though both are NPN transistors, they differ in a particular value, at least one particular value. That may be HIE, HRE, HFE, HOE, whatever, alpha or beta or gamma, any one value will change. No 2 NPN transistors are same. They are identical but differ in at least one value. Right? Here we are using 2 NPN transistors, Q1 and Q2. V1 is the input voltage, V2 is the another input voltage. V1 is the input voltage of Q1, V2 is the input voltage of Q2. RC is the collector resistor of first transistor, this RC is the collector resistor of second transistor. The output we are taking from the collector of second transistor is VO2, and the output which we are taking from the collector terminal of first transistor is VO1. So in dual input balanced output circuit, we apply the input signal to both the transistors. We apply the input signal to first NPN transistor, and also we apply this input signal to second NPN transistor. The application of input to both the transistors at a time, and at the same time we take the output from first transistor as well as from second transistor. Means whatever the signal which we are going to apply at first transistor, the same signal will be applied as the input to the second transistor. First transistor దగ్గర ఏ signal ఇస్తామో second transistor దగ్గర కూడా అదే signal ఇస్తామండి. Right? Why? In order to maintain the balance in the output. Means same kind of output. ఫస్ట్ ట్రాన్సిస్టర్ ఇచ్చినప్పుడు ఏ అవుట్పుట్ వస్తుందో సెకండ్ ట్రాన్సిస్టర్ కి ఇన్పుట్ ఇచ్చినప్పుడు కూడా అదే అవుట్పుట్ రావాలి. మీన్స్ టు గెట్ దట్, ఇన్ ఆర్డర్ టు గెట్ ది సేమ్ కైండ్ ఆఫ్ అవుట్పుట్ ఎట్ ఫస్ట్ ట్రాన్సిస్టర్ అండ్ ఎట్ ది సెకండ్ ట్రాన్సిస్టర్. To do that, what we have to do, the signal which is applied at first transistor and the signal which is applied at the second transistor must be same. Then only the output gets balanced, otherwise output may not balance. See, as we know, a NPN transistor acts as a switch, isn't it or not? Will you obey that or not? This type of circuit we discussed in the DSP last unit, DSP logic families last unit. So transistor acts as a switch. In ECA and in EDC also it was there. Elago chudandi. If you take the transistor, NPN transistor, for the NPN transistor, if you apply 0, transistor Q goes to off stage. And if you apply 1, transistor goes to on stage. If transistor gets into on stage, it acts like a on switch or short circuit, like this. If transistor gets into on stage, the collector emitter terminal gets shorted and current flows from VCC to ground, like this. If transistor is in off stage, means if you apply logic 0 with 0 voltage, then transistor goes to off stage. If the transistor is in off stage, it acts like a open switch or disconnected wire. Open switch or disconnected wire means the circuit or the transistor which does not allow the current to flow from collector to emitter terminal. So because of this reason, we can say that transistor acts as a switch. If you apply 0 volts, transistor remains in off stage. If you apply more than 0 volts, greater than cut-in voltage, transistor gets into on stage. In on stage, it acts like a short circuit, means on switch. That's why I'm telling you that the transistor acts as a switch. Because here we needed that. In case 1, let us take the case 1. Before applying case 1, consider the input signals. The signal which we are going to apply at first transistor and the signal which we are going to apply at the second transistor. V1 is equals to V2, which is equals common mode voltage. Means, say for example, at V1, we are giving a sinusoidal signal with 5 volts amplitude. Same signal you have to apply here. A sinusoidal signal, sine wave with 5 volts amplitude. Here 6 volts is there. Here also you have to apply 6 volts. 10 volts, 10 volts. 1 millivolts, 1 millivolts, whatever it is. But the signal which is applied at first stage and second stage, for the first transistor and second transistor input, must be having same amplitude, same time period. Okay. Now consider the input voltage V1, which is equals to V2. Both are same voltages we are giving. What is that voltage? That is common mode voltage we are giving. Common mode voltage means here indeed diagram apply chesedi okate voltage and meaning. Common mode means. Okay. Then as we know that transistor acts as a switch. Transistor acts as a switch. We know that. If you apply input is equals some 5 volts, transistor goes to on stage. If you apply input is equals to 0 volts, transistor goes to off stage. So because of this reason, we can say that transistor acts as a switch. This is introduction. Now let's see the circuit operation. Case 1. First case, if V1 is equals, V2 is equals VCM. Input voltage V1 is equals input voltage V2, which is equals a common mode voltage we are applying. Due to that, both the transistors, common mode means a sinusoidal signal with more than 13 voltage amplitude. Means say for example 5 volts amplitude, then both the transistors gets into on stage. Q1 is equals to on, Q2 is also in on stage. Both the transistors gets conduct. If both transistors conduct, then which produce the output current, that is emitter current, which produce the emitter current IE1, and this transistor produce the emitter current IE2, IE1 and IE2. And the current which is produced in the collector terminal, this current is IC2 current, and this current is IC1 current. Current which is flowing through the collector terminal of first transistor IC1, current which is flowing through the collector terminal of second transistor IC2. And here, because of these two transistors are in on stage Q1 and Q2, then the current produced by the first transistor is IE1, current produced by the second transistor is IE2. And this is the IE current, sorry, IQ current. Instead of taking it as a, this is a emitter resistor, and this is negative voltage minus VE. The current which flows through the emitter resistor is a emitter current. But here we have already taken the emitter current. For convenience, let us take the current which flows through the emitter resistor is IQ current. That is quiescent current ankondi. IQ current. Right? Now, this is a node, emitter node. This is a node where both emitter terminals are connected. This is emitter of first transistor. This is emitter of second transistor. Both are connected at one point. And emitter resistor also connected here. So this is a node. The name of the node given here as E, emitter node. Right? So apply KCL at node E. Apply the KCL at node E. Apply Kirchhoff's current law at node E. Then what happens? What is Kcl rule? Sum of current entering into the node is equals to sum of current leaving the node. See, IE1 is entering into the node, IE2 is also entering into the node, but IQ is leaving, moving away from the node. So I can write it here. IQ is equals to IE1 plus IE2. IE1 plus IE2. Here, both the input voltages are same. Both NPN transistors. Then IE1 is equals to IE2. Then IE1 becomes equal to IE2. Because both are identical transistors and we apply the balanced input. Then emitter current 1 of first transistor is equal to emitter current of the second transistor. Then what happens? See here. If IE1 is equal to IE2, substitute in this equation 1, then IQ becomes IQ is equals IE1 plus IE1, which is equals to IE1. So IQ is equals to IE1. From this, I want to write here it as IE1 is equals